For this week's article related to obesity, I chose an in-text article that is on resting metabolic rate after a 20-week endurance training program. So just a little background, resting metabolic rate, the RMR, accounts for about 60 to 70% of a normally active individual's total daily energy expenditure. Both resistance and endurance training have been proposed potential interventions to increase resting metabolic rate. And they believe this can happen in resistance training through increasing fat-free body mass, which would then increase resting metabolic rate. And then endurance training could increase resting metabolic rate through its possible effects on increasing the activity of thyroid hormones and the sympathetic nervous system. Studies have suggested that an increase in RMR as a consequence of exercise training is transitory and most likely would last about less than a day, so 24 hours. And the effect of exercise on RMR may be similar to the effect of exercise on insulin action. Most of the effect is in response to an acute bout of exercise and is only minimally associated with chronic adaptations to exercise training. So they're going over the research literature and basically saying that there's mixed views regarding the effects of endurance and resistance training on resting metabolic rate because what scientific literature isn't inconclusive. So the purpose of this particular study was to investigate the effects of a 20-week laboratory monitored endurance exercise training program on RMR in a large group of previously untrained men and women. In order to test this hypothesis that the change in resting metabolic rate is a direct result of the previous bout of exercise or an acute effect and not a chronic adaptation to exercise training, they made sure the RMR was measured on 2 separate days of pre-training to establish reliability. And then they also measured it 24 hours and 72 hours after the last exercise training bout. For the methods, the subjects were all families, including natural mothers and fathers, and you can see their age, height, and weight in the table. Each of the subjects completed multiple testings before the program, which included a RMR measurement using the metabolic cart, which you can see in the photo on the bottom right. And the training was then conducted on a cycle ergometer, and that was linked to a computerized system that was able to control power output. So first, subjects started training at a heart rate equivalent of 55% of their VO2 max for 30 minutes a day. Then they gradually progressed to 75% of their VO2 max for 50 minutes a day at the end of 14 weeks. Then they maintained this intensity for the remaining 6 weeks. And for all exercises, the frequency was 3 days a week. RMR was defined as a subject's metabolic rate in the early morning after a 12-hour fast. Subjects maintain a record of all food intake for the 36 hours period prior to the first RMR test, and then they were told to follow a similar dietary regimen before all subsequent tests. Then subjects also were told to refrain from strenuous exercise of any kind for at least 36 hours prior to training, as that could affect the resting metabolic rate. And also the subjects wore a heart rate monitor from the time they went to bed the night before testing until the end of the measurement for the RMR the day after. Subjects were told to complete minimal movements before the measurement, so they weren't allowed to shower in the morning when they woke up. They had to do all that at night. They were allowed to walk very minimally, so they weren't allowed to walk more than 100 meters from their house to the car that picked them up or from the car to the laboratory. So they're very strict about that. And then their metabolic rate was measured using the metabolic cart for 30 minutes. And one thing I want to note is that water was allowed ad libitum between the fast and measuring RMR, because obviously water doesn't have calories, so it cannot increase resting metabolic rate. But other than that, they were fasted and could not have any food until after the measurement. Maximal exercise tests were conducted on a cycle ergometer 2 times before and 2 times after the training program. It was used to establish the training work rates. So everything was used individually, and the average of the 2 tests were used to determine the relative increase of VO2 max as a consequence of training. Body composition was also measured through hydrostatic weighing. Each subject had to do 10 trials, and the highest 3 weights were averaged, and that's what they analyzed. In my opinion, 10 trials of hydrostatic weighing is a lot. For me, just 1 was enough, but I guess they got a pretty good idea of what their body measurement was. And then they also took a resting blood sample to be analyzed for thyroid hormones, but for whatever reason, they never actually used those blood samples, so they really didn't do anything with them. For the results, reliability across the 2 pre-training trials, according to interclass correlations, was high for the resting oxygen consumption, energy expenditure, resting metabolic rate, heart rate, and the sleeping heart rate, as well as VO2 max. The interclass correlation for the resting RER was significant, but it was considerably lower. Endurance training program resulted in an increase in VO2 max of 17.9%. So that's a pretty big increase. And you can see over on the right, for body weight, total body weight wasn't significant at all between pre-training and post-training, but relative body fat, fat mass, and fat-free mass were all affected, and they were significant. There was no change in the RMR as a consequence of endurance training, either 24 hours or 72 hours post-training. The RER decreased slightly from pre-training trial 2 to the 24-hour post-training trial 3. So even though there was a change, the RER returned to pre-training values by 72 hours post-training. And there was a small but significant decrease post-training in both the RMR and sleeping heart rates. And you can see the differences in the trials, the 2 trials for both pre-training and post-training below. As a result of all the information that they gathered, basically this study did not support the hypothesis. There was no evidence of increased resting metabolic rate at either test period for the post-training. So although there was a small decrease in resting heart rate after training, that would suggest, that the training program did not result in a significant effect, but the mean increase in VO2 max of 17.9% supports that there was a substantial cardiorespiratory training effect. And to me, that would be a benefit. The change in body composition agrees with the results of previous studies. So although total body comp didn't change, there were significant changes in their fat-free mass and their percent body fat, which is an improvement. And then other longitudinal studies have shown an increase in RMR with exercise training, but this particular 20-week endurance training program showed no effect on resting metabolic rate, and they said they even accounted for potential confounding effects such as age, sex, and body composition. So the question is, what worked for them versus, what didn't work, and how we can see, of course, an increase in RMR in some studies, but not in this one. And I guess we'll have to look into that.